Hey everyone, Vector here. You're getting a bonus short from us today, and this one is a little different.
Hi all. We're previewing a new Thursday segment called Beyond the Token. The full segment officially joins the Thursday rotation next week, on the 11th. Today is just a taste.
Right, and the idea is simple. The LLM news cycle has its own gravity, and it eats every other story in AI. Beyond the token is the rest of the field. Diffusion models, video generators, audio synthesis, world models. The non-LLM half of the stack.
And specifically, the how. Not this thing exists, but what structural choice the lab made and why that choice matters.
So 3 stories today. Ideogram 4, NVIDIA's Cosmos 3, and Gemma 412B. Take it away.
Let's start with Ideogram 4. They released the weights openly this week. The headline story is that it's the first major open weights image model built around flow matching for high-fidelity text rendering.
And flow matching is the architecture, not the model name. Important distinction.
Exactly. The previous generation of diffusion models used something called DDIM, denoising diffusion implicit models, which trace a curved path from noise to image. FlowMagic learns a straighter path. The practical consequence is fewer sampling steps for the same fidelity, and notably better structural coherence on text inside the image.
So when people post screenshots of AI-generated movie posters with the title actually spelled correctly, that's the flow matching payoff?
Largely, yes. The other architectural choice is a single-stream transformer, where text and image tokens are concatenated and run through the same layers, rather than 2 separate branches that fuse late. It collapses the cross-attention bottleneck.
And the community already found the safety filter and is bypassing it through a comfy UI node. Open weights means open weights.
The vendor's claim that it beats GPT Image 2 and Midjourney is currently based on a single leaderboard, and that hasn't been independently tested. Mark that one as a claim until third-party benchmarks land.
Next up, NVIDIA Cosmos 3. This one is a world model, not an image model.
The architecture here is the interesting part. It's what NVIDIA calls a mixture of transformers. 2 towers. One tower is autoregressive and handles reasoning and perception, like a normal language and vision model. The other tower is a diffusion transformer, and it handles the generation of pixels, audio frames, and action trajectories.
Trajectories meaning what exactly?
Robot motor commands. The structural shift is that in the previous generation, the pipeline was 3 separate models. One understood the scene, one generated video, one produced robot actions. You chained them together, and errors compounded at every handoff.
Right. 3 models, 3 points of failure.
Cosmos 3 fuses them. The reasoning tower and the generation tower share a positional embedding, so chain-of-thought reasoning can output a motor command in the same forward pass that generates a predicted video frame.
So a robot can dream the task before doing it?
That's how NVIDIA is marketing it, yes. The catch, and this is in their own technical report, is roughly a 30% performance drop on what they call rare rigid contact events, precise mechanical assembly, snapping parts together. The model is great at soft interactions and bad at hard ones.
And NVIDIA's zero-shot robotic control numbers haven't been independently verified yet either. So another claim until someone outside their lab confirms it.
Third story. Gemma 412B from Google DeepMind. This one is structurally the most aggressive of the 3.
How so?
Every previous multimodal model used dedicated encoders, a vision transformer for images, an audio encoder for sound, and then the language model on top. Gemma 4 removes them entirely. Raw image patches and raw audio waveforms project directly into the language model's embedding space through a tiny linear layer.
So there's no translator step between modalities. It's all one model, one embedding space from the first layer.
That's the structural claim. The argument is that dedicated encoders create a bottleneck. They were trained on a different task than what the downstream language model needs, and information gets lost in translation.
And the cost of doing it this way?
Spatial blindness. Without a dedicated vision transformer, the model sometimes miscounts objects in dense scenes. A separate vision encoder would catch what Gemma 4 misses.
And the hardware story?
Local. It runs on a laptop. That's the editorial hook. 16 gigabytes of VRAM, which is consumer hardware now. The encoder-free architecture is what makes it small enough to fit.
All right, overflow round. Quick hits on what we did not get to.
NVIDIA also dropped PIDE, a pixel diffusion decoder, which replaces the standard variational autoencoder at the end of a diffusion pipeline with a generative diffusion process at the pixel level. It fixes the washed-out color problem in several major open models. Worth watching.
Meshflow, out of Meta and the CVPR community, is doing the same architectural shift, but for 3D meshes. Flow matching instead of autoregressive, so a whole mesh generates in parallel instead of vertex by vertex. Faster.
Echo Infinity is solving infinite-length video generation with a learnable memory module instead of a hand-tuned cache. They demonstrated continuous video runs of over 24 hours.
And Google rolled out a fake call detection feature on Android. The interesting part is the architectural choice. They stopped trying to detect deepfake voices and started verifying real ones through a network handshake. Identity, not impersonation.
Tokens are the least interesting part of the story this week. That's the segment.
That's the preview. Beyond the Token launches officially next Thursday, the 11th, inside the normal neural data. Same hosts.